first. Yeah, we're definitely going to online for this for a while and see what happens. Because, oh my good gravy. All right, questions about your homework from last night.
Okay. 15 and
Okay, so let me start with 15. All right, so 15 says model the data algebraically with linear equations of the form y equals mx plus b. Write one equation for the women's and another one for the men's. Use the 1954 and 1999 ordered pairs to compute the slopes. So if I look on the table 1-6, you've got all these years listed there, right? For the female, 1954 was 32.3 and 1999 was 58.5. And for the male, 1954 was 83.5 and 1999 was 74.0. So we'll do female first. You want to do male first? So these 2 points for the male would be 1954, 83.5, and then 1999, 74. And so I'm going to go through first and find the slope. Remember that's change in y over change in x. So 83.5 minus 74 over 1954 minus 1999. I don't know what that is because I don't have my calculator. Anybody? Okay then. Did y'all not do it, or 83.5 minus 74? Okay. 9.5 over what? Negative 45. It doesn't matter which one you start with as long as you start with that same point on the bottom. So if I'd started with 4 up top, I need to start with 99 on the bottom. So either way is fine. If I divide by 45, then I get, what is that in a fraction? 0.21111 repeating. What is that? Anybody hit math enter and get the, what is it? Yeah, for the slope. Oh. Okay. I left it as that. You left it as, well, this fraction would be 95 over 50. And then you'd have to reduce it. The same thing. I just moved both decimals over one. So I didn't have, and then I could simplify it. What's the bottom? Now I need to, it asked me for slope intercept form, right? And if you've done this on your calculator, just divide them out and then hit math enter. It's going to give you that fraction in the simplified form. So I take either one of the points. It doesn't matter which one. Let's say this one. It doesn't matter which one you use. And I'm going to do y minus 74 equals negative 19 over 90 times x minus 99. Now it asked it for me in a specific form, and this was part of what we tested on Friday, is that we can get from form to form. So here I would need to distribute. So y minus 74 equals negative 19 over 90x plus, anybody on that one? like 400. I'm going to just round it to 422.01. If you multiply through here, divided by 90. And then I'm going to add the 74 to both sides. So I get y equals negative 19 over 90. If I had my calculator, I'd have an exact fraction for you here, but that's close enough. No? Did I do it wrong?
I didn't do that because I jumped about it on the
I'm not wrong. So what I'm going to say that what they probably did I was going to say, so instead of doing 1999, they probably did something like 99 for x instead of using 19. You see what I'm saying? Or they let x be the number of years since a certain year. Right, right. But this is fine. Do I need to do the women's too? Yes. So do you want to do the last? Okay, so the only problem with doing the last two digits is when you do the last two digits, you're going to hit 100 at some point, and that's going to roll you over to 2000, right? See what I'm saying? Because if you do 95 for 1995, then 100 is going to be the year 2000. Does that make sense? You see what I'm saying? Because if 95 is 1995 and 99 is 1999, then 100 would be the year 2000. So that might get confusing for you. Okay, here we go. So these 2 points are 1954, 32.3, and 1999, 70, nope, 58.5. So same process, find the slope first. 58.5 minus 32.3 over 1999 minus 1954. And so 58.5 minus 32.3 would be 26 point what? Over, again, negative 45. Positive 45. So 26 points. Let's just do a fraction, a decimal for this one. 0.582. And then use one of those 2 points to form your equation. So y minus, I'll use this one, y minus 58.5 equals slope times x minus 1999. Y minus 58.5 equals 1,163.86. And then if I add the You should. Should be close. Might have one being error there. That's not what you got. So you know what they did? I see what they did now. They let X be the number of years since 1954. Okay? So they let this point be 032.3. And then they let this point be 4558.5. So that when they found their slope, and they went through and found that slope here, they used this as their y-intercept. So they said y equals 0.582x plus 30.3, because b is your y-intercept. I'll tell you if I want it exact. If I don't specify, you can do it either way. All right, what else did you say on your homework? Analyzing the numeric table of values. So that if I give you a table, you can do analysis on it. We analyzed the employment statistics of females versus males from 1954 to 2004. It should. What else? Anything else from your homework? B from 24? Oh. Part B says from 1994 to 2000, the data seems to follow a linear model. Use those 2 years to find an equation for the line. And superimpose the line on the scatter plot, because in part A you were supposed to graph. So let me ask you this. When you graphed it, did your x-axis, did you go, when you did this on your scatter plot, this first, is this a 1 or is that 1994? Okay, then we need to use 1994 as the x value. See the difference there? If you use 1, then that would say the number of years since. But if you use 1994, then we need to use 1994 as we calculate. All right, so 19, and what are we, okay. So this is 5288, and we'll just use decimals here since they use decimals. 2000 is, 666.2. Slope here would be, y'all are like, zombies this morning. $22.9 slope. Is that what y'all got? $22.9. So then y minus 528.8 equals 22.9, x minus 1994. Did it say slope and, oh, it didn't say what form here. I would leave it there because it didn't tell me what form it had to be in. All right. Y'all ready for today's? So, in our prerequisite chapter, we talked a lot about solving quadratics, different ways that we solved quadratics, and really the only way we talked about solving other equations was graphically, right? So we're going to talk about some ways of solving other a little bit funkier type graphs, or equations, excuse me, and then we're going to talk about some graphs that we have to really kind of manipulate to see. And we did a lot of that last year, so y'all should be ahead of the game here as we go. All right, so we're still in 1-1. This is 1-1 day dose. Let's say that I gave you something like, and I said solve. Walk me through what we could do here. Set it equal to 0. That's always a good place to start, right? And let's say we're not using our calculators on this one. If I set it equal to 0, what should I move? Why? Good job. I want to keep that leading coefficient positive if I can. Did you know that? Or are you, what are you? I'm always going to try to leave that first term positive if I can because it's going to make my life easier in a lot of different scenarios. So I'm going to move instead, I'm going to move the 11x squared and the 10x over set equal to 0. What could I do now? Oh. Sorry. You could take out an x for sure. I could take out an x, right? If I take out an x, and now I'm in a situation where I have a quadratic, and what could I do? Factor. What multiplies to negative 60 but adds to negative 11? Negative 15 and 4. Several of you forgot this on your test as I'm going through them. I'm almost done, by the way. You have to multiply the first and the last together. It's not just the last number, it's the first and the last together. And then it's what multiplies to the product of the first and the last, but adds to what sits in the middle. And then we rewrite that middle term. So now I have x times 6x squared. It will benefit you if you start with your negative here instead of the positive, but you don't have to. Minus 16x plus 4x. What? This is exactly the same equation. The only difference is I wrote negative 11x as negative 15x and positive 4x. I just wrote it a different way. Now I'm going to slash it. Oh my gosh. And I am going to GCF the pieces here. So what can I take out of 6x squared and 15x? What's left? Middle sign stays. What can I take out of the last two? And what's left? So it factors as, I've got this common binomial here of 2x minus 5. And that factors out, and it leaves me with the 3x plus 2. So that's all well and good, but what good does it do me here? How does it help me to solve? I can set them all equal to 0 because no matter how many pieces I have multiplying together, if they equal 0 when they multiply, then any one of them equaling 0 would satisfy the equation. So x could be 0. Clash Royale, Brett. 2x minus 5 could be 0, or 3x plus 2 could also be 0. So if I solve each one of those equations individually for x, here I would get 2x equals 5 over 2. And I hope, well, and I hope at this point, and if I need to, but I'm not doing plus 5. I mean, can you guys see that one step at a time without me actually? Right, okay. All right, everybody okay there? Yeah. Let's crank it up a notch then.
Okay, why did it throw in the square root sign?
Solve that for x. Yeah, I'm gonna need a little bit of help on that. Okay, well let's rewind back to algebra 2. When we solved radical equations. Okay, but if I that what did happen in that chapter, but not with this. You made me lose my train of thought. If I square both sides the way it sits now, I'm going to still end up with a radical, and I'm not going to be able to do anything. If I have one radical in the equation, I need to get it by itself first. You remember that? Okay, so to get it by itself, I need to move that x. I need to subtract that x over to the other side. So when that x comes over here, I end up with the square root of x equals 1 minus x. Is anyone confused? Because I need to get, before I can get x by itself, I need to get rid of the radical. And to get rid of the radical, I need the square. Right? If you had squared it here and here, you would end up with square root of x plus x. Square root of x plus x. And watch what happens when you FOIL it. Yeah, that would be x, but then I'd have x times the square root of x plus x times the square root of x plus x squared. I still end up with a radical in my answers. I didn't get rid of it. So in order to get rid of it, I need to get it by itself. Because once it's by itself, it's gone. Right? So now I have x equals, and do not distribute that exponent because it doesn't distribute. That minus inside keeps me from distributing it, right? Say right, because that's right. Thank you. 1 minus x. And FOIL. No. Yes. I'll give you just a second to catch up with me. A stylus. Now this is a quadratic, so now we're back in familiar territory, right? This should be easy for us now. Make it equal 0. That's right. And I'm just going to rearrange this to look a little better. So x squared minus 3x plus 1. What should I do? Why? Why are you doing quadratic formula?
It doesn't work. You can't look one person.
It's not factorable. So I am down to quadratic formula or completing the square. Want to complete square? Okay. I like completing the square. All right, so if I take half of 3 and square it, I end up with 9/4. That's going here, and it's going here. Factored on the left would be x minus the square root of 9/4, which is 3/2. And I need to combine these two. -1 is going to be -4/4. So I have 5/4. Once you get to this point, it's easy peasy. I agree that completing the square, whenever you get familiar with it, is a lot easier than quadratic formula if you don't have a leading coefficient here. Square root?
So you just put 4/4 as 1?
Yeah. So they had common denominators. Is everybody okay? A lot of chatter about, is it the completing the square that's throwing everybody?
The fractions are messed up.
It goes away. Right. Yeah. You don't have to rationalize. And that's the nice thing about completing the square is it's always going to be a perfect square on the bottom, so you won't have to rationalize if you do it correctly, because you added a perfect square denominator over there. So you've found common denominator. So 9 times out of 10 it's already going to be. Yeah.
So you don't put the x in the.
What you mean?
Like I thought you do parentheses x plus square.
Well, I did. Well, it's minus because
Oh,
it's the first sign. So it's the square root of this one, and it's the square root of this one. No. So remember the point in completing the square is that we get a perfect square trinomial, and then we factor it this way. Guys, and we're going to get, you need to be able to do completing the square this fast because we're fixing to get to a point where we are going to have to redo some forms, and the only way to do it is by completing the square. So you need to be very comfortable with completing the square. That's why we spent time on the front end on completing the square. So make sure you can do that, yeah. It is, when you're completing the square, it's a lot easier to keep it in fraction form than it is to switch it to a decimal. Somebody had a hand up over here. Okay. Okay. All right. So this becomes x minus 3/2. The square root of 5, there is no square root of 5, so I leave it square root of 5. The square root of 4 is 2. And I throw that plus or minus in front because I did take the square root, which makes me have a plus or minus. And now all I have to do is add that 3/2 to both sides. And since they have the same denominator, if you would like to combine these over the same fraction and make this 3 plus or minus square root 5/2, if you had done the quadratic formula, you would have come back to that exact same answer. That's where I factored the perfect square trinomial.
I don't know what I'm doing. Wait, so I've been.
We'll give y'all a second to digest this because it seems like we're having.
She put the square root of 4 was 2 times square root.
It's okay. All right. Take out your calculator for a second. I want to talk to you about some times when there are things on our calculator that we don't see and how we adjust. And you should know how to do this. Some of your homework is going to be solved by graphing, and you're going to have to adjust that window to see some. So I want to take just a minute and make sure you can adjust that window to where you can see the entire graph and you can tell exactly what's happening. And we're going to look at two different equations here. So this is what we call hidden behavior or graphing failure. If you don't need it, no. Let's look at the failure part first. What happens when your calculator doesn't know what it's talking about? Before you graph this on your calculator, I want you to find the zeros algebraically. What does that mean? What is a zero? That's okay. A zero is when the...
What's the top?
Yeah. Yes. I'll tell you. If you want to. It's not going to take a whole lot of room. I want you to first find the zeros. So how do I find zeros of any function? What does it mean to be a zero? An x-intercept. And what's true about every x-intercept? Crosses the x-axis. It's a solution. A solution to what equation? A solution to what? When a solution when something equals 0, when y equals 0. So to find zeros algebraically, I'm looking for places where y is 0. Would you agree with that statement? Okay. So if I take this equation and I set it equal to 0, tell me what you get for x. In other words, solve this for x and tell me the answer. So do that on your own quickly. You don't know how to solve that? You don't know? I just added that whole fraction to both sides. I just took that fraction and added it to both sides. I moved it to the other side. I'm trying to get x by itself. I'm going to square both sides. I got to get rid of, now that I've got that radical piece by itself, I need to get rid of it. All right, so now that I've got that radical piece by itself, I need to square it. All right, so I end up with 1 over x squared minus 1 equals 9. Do you all agree with that? Okay. How do you solve something with a variable in the bottom like this? Okay. Or cross multiply, which is the same thing, right? So 1 equals 9 times x squared minus 4. Or I could just flip both sides, right, if I need to. You should be able to solve this at this point, right? Get x by itself, divide by 9. I have 1 over 9 equals x squared minus 1. Add 1 to both sides. Close. Yes. You could. 1/9 plus 1. I need common denominators, so it's 1/9 plus 9/9, which is 10/9.
Is it x squared equals 1?
Square root of 10 over
Is that right?
Square root of 10 over 3.
Oh.
Oh, could you? Oh, okay.
Wait, so
You
you
can start with 9. But it's certainly is not.
Can you see
No,
what I
she's
did
not
wrong?
a lost cause.
Can you see what I did wrong? I just did not
9,
get
you
that.
got 9x squared, all right, so you added 9. 1 plus 9 is 10.
Oh. Okay.
What you think?
All right, I didn't anticipate getting caught up in the solving there. I'm sorry. I was thinking that I was proving a point here. No, Miss McGee was not unprepared. Do you agree that this function crosses the x-axis in 2 places? It has 2 zeros. Algebraically, it has 2 zeros. Do you agree? It's a plus and a minus, right? Are we all in agreement?
Yes.
Graph this same one on your calculator. So go back to the beginning and put this in y equals and do a zoom 6 on it and tell me what you notice. Zoom 6.
How do I put this?
Oh my god.
I don't. What do we put in our calculator?
All right. Oh, why does yours look like that? What is going on? Oh, my calculator died.
Oh, mine's like a. Oh, what the heck?
When you graph it, you are probably getting something that looks kind of like this.
It's x squared minus what?
Did you put parentheses around the denominator of that fraction?
Oh, I got that.
And you did x.
How's your Wait, what is that?
The point that I'm getting here, and you're going to have some on your homework that look like this. If I were just to graph this and trust that my calculator graphed it correctly, I would go, oh, no zeros. But actually, it does have zeros, right? We know that it has zeros. We know that this actually continues down and there's a 0 here and a 0 here. Okay, so this is what we call graph of failure. Yeah. Yours graphed it all the way down? Oh, good. Some of them now, maybe they do then. I don't know. Interesting.
Oh, now it's black. Oh,
Hmm.
so
Okay.
wait, normally it would look like just lines that just stop.
All right. Yeah. Huh? That's what we're looking at. Just to if you see that it doesn't have one, make sure algebraically that you would get an imaginary number or that it's not solvable or something whenever you. So it's just being familiar with. It's really that we can solve it both ways and know that. Not on your calculator, no. You have right. All right, well, you got the right equation. Yeah. All right. Just quickly, one to show you that you can't see if you just do a Zoom 6 on. If you do, let's see. Let's say I asked you to find the zeros here. Grab that and see what it looks like. Put it on a regular Zoom 6 window when you do it. So a 10 by 10 window. You're going to get something that looks kind of like this if you just do a 10 by 10 window. So I just want to make sure everybody remembers how we zoom out without actually hitting zoom out. Okay, so if you hit that window button, yeah. If you hit that window button, remember the X-min and the X-max is how far out you need to see. And I look like I can see pretty good left to right. It looks like the up and down is what I need to adjust, right? So if you look at your Y-min and your Y-max, if you change that Y, I'm just going to tell you, you'd play around with it, but I'm just going to tell you because I have it here in front of me. If you change the Y to negative 500 and you change the Y max to 500, click that and then look at the picture at what a better picture it is of that graph. It should look something like this now. Yeah. Yeah. You wouldn't, but if you were looking for the it maxes or mins or anything like that, yeah, you would.